Thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Welcome back to the second week of Concentrator Talk this year, brought to you by Oxygen Alliance. My name is Sharon Ngozo, and I'm currently in Lilongwe, Malawi. I'm pleased to be hosting the call today. I've been joined by my colleagues today, Mawe Lungu and Fatani Tamandikani, alongside our usual technicians from Open02 and Sunlight. On the technicians panel today, we have Paulina Mohoto, Masofra Mujaj, Goinda Singh, Eunice Msisha, Naomi Thompson, Oblish Nkunda, and Kevin Said. In case you're just joining us for the first time, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday, 2 to 3 p.m. Central African Time. And here we discuss different aspects of oxygen concentrator assessment, maintenance, and use. So if you have any questions regarding oxygen concentrator assessment or maintenance, that you might need help with, we always encourage you to keep in touch with us through our email info@oxygenalliance.org, and our technicians will do their best to assist you with the best solutions. So if you have any questions for us during the call that maybe you might need to ask relating any questions that we'll be discussing, feel free to raise your hand or you can paste in the chat and I'll read it out. So as usual, we also have a topic of interest today, and Kevin Saidi will be talking about ways of reducing humidity. So now to jump into our questions. The first question says, good afternoon. I'm a biomedical engineer intern working at a certain hospital. We have a DVB 525 that is producing low purity despite the fact that we have just refilled the sieve beds with new zeolite. I was troubleshooting to see what the problem might be and noticed that there are some valves that connect the product tank and the sieve beds. In contrast to the other valves, one appears to be allowing air to flow in both directions when blown on. Is this a typical situation where one valve should permit air to pass in both directions? If not, may this be the reason for the outlet's low purity output? So I'll ask one of our technicians to answer this one.
Okay. The connection between the sieve beds and the product tank for the DeVilbiss 525 oxygen concentrators are fitted with valves that are known as check valves or one-way valve. These are the valves that allow the flow of fluid in one direction only. In the oxygen concentrator, the air passes through the zeolite in the sieve bed and is fed into the product tank through the check valves. Since the air is at a high pressure, the check valves prevent a backward flow of the air when the sieve bed depressurizes, when feeding has switched to the other bed. If the check valve is faulty, it allows air to pass through it in both directions. This will mean that air can flow back to the sieve beds from the product tank. This will cause a drop in the oxygen concentration that is being accumulated in the product tank, since some of the purified air is going back to the sieve beds. Now, to answer your question, yes, that one valve that is allowing air to pass through in both directions is the cause of the drop in purity for your unit. You therefore need to replace this valve with a new and functional one. Also proceed to check the integrity of the other valves to be sure if they are working properly. Thank you, Sharon.
Thank you very much, Paulina, for that explanation. Any comments from the fellow technicians or questions from the audience? Okay, if we have no comment and questions, we move on to our next question, and it says, hello, I'm a biomedical technician at Mcheo District Hospital, and I've noticed that the oxygen concentrator we're using is making a lot of noise. when the sieve beds are releasing nitrogen into the atmosphere. The noise is too loud and very disturbing for the patient. What can be the problem and how can we solve this problem? I'll ask one of our technicians to answer this one.
All right, I'll take that one. Thank you very much for the question, Sharon. So, every oxygen concentrator undergoes the process of pressure swing adsorption, where the ambient air is filled with nitrogen, which is then absorbed by the zeolite in the seed beds at a higher pressure. After the adsorption process, the remaining oxygen is further filtered by a bacteria filter and then directed to the patient outlet. There are two seed beds in an oxygen concentrator and they work alternatively. As one seed bed is fed with ambient air for the pressure swing adsorption process, the other seed bed releases, or in other words, exhausts the adsorbed nitrogen to the atmosphere and then vice versa. When you notice that during the exhaust of the nitrogen there is too much noise, then it's either the exhaust muffler is broken, or it's not positioned properly, or it's not even there at all. My fellow technician Aubrey, we've been together in the field and he has ever encountered a problem with the muffler before. Before, when one of the interns he was supervising had a problem with the muffler, I would just ask him to share the experience and how they fixed it. So, Aubrey.
Thank you very much, Eunice. That's very true. We have encountered a scenario like this one before, where we had a J5 concentrator that was brought to me. It was producing a lot of noise. Prior to that, an intern had been working on this machine, and after I troubleshot the machine, I realized that when he was replacing the cover or the intake filter, it wasn't placed correctly. So now the machine started producing a lot of noise. And I told him that when you are replacing the cover to the filter, make sure you place it properly. So we carefully placed it back in position, and then all the noise went off. So it is important that you make sure that when you're replacing the covers, you should make sure you replace them right in the right position when conducting the preventive maintenance. Thank you. Back to you, Eunice.
Thank you very much, Aubrey, for sharing your experience. So, indeed, it is very important to pay attention to such details which can cause problems if not done properly. So, as we've heard from Aubrey's explanation, an exhaust muffler is a device used for reducing the noise emitted by the exhaust as nitrogen is released should be positioned correctly. If it is severely damaged or not there at all, please replace it with another exhaust muffler, or you can seal it with an adhesive if the muffler is just cracked. Because most of these mufflers are made of plastic, so if you can have an adhesive, for example, plastic, it can actually help you seal that crack. So an oxygen concentrator is supposed to have this muffler, otherwise it will produce sound that can be very uncomfortable to the patients. So an oxygen concentrator cannot operate without this device because we'll be hurting our patients. So make sure that your concentrator should always have the muffler. Thank you very much, and back to you, Sharon.
Thank you very much, Eunice, for that well detailed explanation. And thank you, Aubrey, for sharing your experience. Okay, we have a hand from Mulugeta Mideska. Please, if you have a comment or question, you can go ahead and ask.
Thank you, Sharon. Especially for my comment was especially the second one. The sound is coming mostly from the muffler. Already it is answered, and that's right. You can change it the muffler, and you can use a muffler. So most of the time, the muffler is removing from the to evacuate nitrogen. So it seems the high sound is created. So that is a muffler. For the first question, not only for the one-way valve, there is also the equalizer valve. When the seed beds are, one is producing oxygen, the second one is deoxygenized, or what you call it, discharging the nitrogen. So there is one valve that is said to be equalizer valve. That is two-way valve, but that works for the potential difference. If the maximum oxygen is coming from one seabed, the other will be empty. So when they are reaching after 7 seconds, they stay opening for 1 second to equalizing. So that will have it will also help us to the second valve to be ready for generating oxygen. So that is the equalizer valve, not only for one-way valve to the tank. That will be the opportunity to pass in two directions. So you have to check it, the equalizer valve for the first question. Thank you very much.
Thank you very much, Murikita, for that additional answer. Okay, we also have one hand from Kelvin. Go ahead.
All right, thank you, Sharon. So about the equalizer valve, so that was a very good explanation of how it works. But I believe a Devil Beast 525 does not have an equalizer valve above the seatbelt. Thank you.
Thank you very much, Kevin. I guess this can apply for other concentrators that use the equalization valve. Of course, we know that not every model of concentrator that has the equalization valve. So thank you for that. Just a reminder for our new members, please share with us your email in the chat so that we can add you to the emailing list so that we can be reminding you. And also, you should not miss out on every information that we add in at Oxygen Alliance. Okay, so if we have no further question and comments, we move on to our next question. And it says, I'm a biomedical technician at Nkorakoda District Hospital. As I was assessing oxygen concentrators in the pediatric ward, I came across a concentrator which was producing a lot of noise, but the concentrator was being used. I checked the purity at the outlet and it was 90.2%. I decided to take it to the workshop for compressor servicing. The next day, the same concentrator started giving out a purity of 67%. I checked for leaks in the airways, but none were found. What could be the cause of this massive change? I'll ask one of our technicians to answer this one. A hand from Mobley. Go ahead.
Thanks, Sharon. So from the explanation, it has been mentioned that the oxygen concentrator was pulled from the pediatric ward. Given that there were no leaks and the oxygen purity was high the day before, I think there are 2 or 3 possible explanations for this large difference. Firstly, there is a possibility that the concentrator was operating at a low flow rate, since you've already mentioned that it's coming from the pediatric ward. So at lower flow rates, oxygen accumulates in the product tank, and this increases the concentration regardless of the efficiency of the seed beds. So when you measure the purity using the analyzer, it will register a high purity because of this accumulation. So when measuring the purity, you are always supposed to open the flow meter to the maximum and ensure that you're getting the maximum flow. So for example, if you're measuring purity on a 10-liter oxygen concentrator, make sure that you open the flow meter to the maximum, which is 10 liters, and then measure the purity at that flow rate. Secondly, it is important to note that the measuring purity of an oxygen should be done some 5 minutes after the unit has been turned on. When you immediately measure the purity after switching on the unit, you might get incorrect readings because the oxygen in the product tank has not yet stabilized. So you might end up having either high or low readings on the analyzer. And just another thing that can also cause the incorrect purity readings is when you measure oxygen purity just after adjusting the output pressure of the oxygen concentrator on the pressure regulator. When measuring pressure, airflow is blocked, and this causes oxygen to accumulate in the product tank. So there is also a need to always wait after you've measured the pressure and allow the oxygen to stabilize so that you're taking the appropriate readings using the oxygen analyzer. Thank you very much.
Thank you very much, Obli, for that answer. Any comments from the audience or the field technicians or questions? Can we have a hand from Kevin? Go ahead, Kevin.
Thank you, Sharon. So one thing that I've also come to notice is that when you are measuring purity, you need to make sure that your oxygen analyzer is showing the minimum oxygen reading because under normal circumstances, when you measure purity on a high performing concentrator, some of the oxygen remains in the oxygen analyzer. And if you check another concentrator before bringing the oxygen purity down inside the analyzer, you might get a wrong reading due to the mixture of the two gases from different concentrators. So it is important to make sure that the analyzer is showing 21% before you start taking the next reading. Thank you. Over to you, Sharon.
Thank you very much, Kevin, for that additional comment. Okay, so we have a poll at the end of this question, and I'll ask Fatani to launch the poll and try to explain to us how we can access the polls.
Thank you, Sharon. So this is the time for our first poll for this call. I'm going to launch the poll now, and then later on I'll explain how you can access the polls. The first poll reads, have you ever experienced a difference between purity readings? Have you ever experienced a difference between purity readings? I have launched the poll and I'll give the audience time to vote. So in order to access the poll, if you are joining us from your mobile, you go to the bottom right corner of your mobile phone. There you see three dots. Click on those three dots and then choose the activities button and then select pause. If you are joining us from your computer or laptop, also go to the bottom right corner and you'll see an icon for activities button. It looks like a circle. It has a triangular shape, a circular, and then a square shape. So click on that activities button and choose pause. Then you can vote. The votes are coming in, and it looks like most of us have ever experienced the difference between purity readings. This is a very common occurrence to technicians that work with oxygen concentrators, as Aubrey has already explained. Now I'll end the poll, and over to you, Sharon.
Thank you very much, Fatani. Now we move on to the next question. And it leads, I'm a biomedical technician at a certain district hospital. We have purchased 2 oxygen concentrators at an auction. We have tried powering them on and there is no operation of the system and the power failure light is on with an audible sound. What can we solve this problem? I'll ask one of our technicians to answer this one. Yes, go in there.
Okay, yeah. So oxygen concentrators have LED that light up and also alarms that will sound to inform the user about the condition of the oxygen concentrator. For example, if there is a high pressure, low pressure, power failure, or low purity alarm. So any leakage at any point in the system will cause oxygen to be released, leading to low pressure. So the tank will not hold the required amount of oxygen and there will be less oxygen at the patient outlet. So this will also lead to alarm sounding. The power failure alarm that you are getting on your machine is one of the many alarms that oxygen concentrators give out when faced with different issues. This type of alarm indicates that you are not getting any power. So one cause could be that you are not getting any power from your socket, either because of the power loss in the building or damaged sockets. So you might need to try it on a different socket just to confirm. The problem could be a blow fuse on your plug. Please make sure that you verify the fuse in the plug is okay by testing the continuity of the fuse using a multimeter. Try these solutions out and see if they are going to solve your problem. If you are still having more issues, please make sure you get in touch with us so we suggest more solutions to try out for you. Thank you.
Thank you very much, Corinda, for that detailed explanation. Any comment? Okay, Fatani, you have a hand. Go ahead.
All right, so I just want to point out that if you are using a J5 concentrator and you encounter a similar issue, the fuse for the J5 concentrator is placed in a hidden location, and sometimes it might be hard to locate if you're not aware of the location of the fuse. So in the J5 concentrator, the fuse is located just under the port where you plug in the kettle cable. So to access it, you just need to use a small flat screwdriver to pull out the holder, and then you remove it, and then you can continue with testing the continuity as Kuinda has suggested. Thank you.
Thank you very much, Fatani. We also have a hand up from Mulugeta. Go ahead.
Thank you, Sharon. Both speakers suggest the right troubleshooting and the right rectification. So that is the first simplest way, checking the cable. The other is checking the power source and the fuse. Especially, the most common problem is the second speaker says, the fuse is hidden. Sometimes in some concentrator, it is covered by plastic, and you have to search that because most of the time the other fuse does not, they are open, but the main power source fuse is hidden in some concentrator like Yoye and others concentrator brands. The other issue is sometimes when the new concentrator is coming, if there is a power difference, for instance, if it is working for 110, sometimes they are plugging to the 220 in some cases. So there is a move, the so-called move, which is parallel to neutral, and they are connected to neutral and phase. That will be one of the protective devices. That seems capacitor, but it is blown out. So before getting that machine, if they are connecting in the wrong system, so that will be also one of the failurity. If it is not after getting or testing with other person, and they will fail that issues. So this is the common problem. Thank you very much.
Thank you very much for your additional comment. We also have a hand from Obli. Yes, Obli.
Yeah, I just wanted to add from what Mulugeta has talked about, especially the part where it has been mentioned that sometimes you might have concentrators of different power ratings. So maybe one that uses, let's say, 120 volts and then another one 220. So I think this is an issue that I've come across, especially here in Malawi, where maybe most of the concentrators are either donated, so from different parts of the world. So others use either the 120 volts, others use 220. So it's always important to check. Sometimes, as maybe engineers, we get used to just getting the concentrator and then plugging it in, but it's always important to check that this is to check the voltage and the power readings of the concentrator to avoid any damages and accidents that might happen. Thank you.
Thank you very much, Aubrey, for that additional comment. We also have a hand from Kawinda. Go ahead, Kawinda.
Yeah, that is the problem of voltage. Means some machines are designed to work on 120 volt and some are on the 220 volt. So we have also faced such problems during last times in India also. The donated machines, some were 120 and some were 220 volt. So in that case, we suggest the user to use a stabilizer, step down transformer, you can say. So that is like a stabilizer. So that stabilize the volt from 220 to step down the voltage from 220 to 120 volt. So that can work in that cases. Yeah, that has to be checked before purchasing or using the machine. Thank you.
Thank you very much, Kawinda, for that comment. Okay, thank you all for your comments. So if we have no further comments, we move on to our next question. And it says, hello, I'm a nurse at a certain hospital. A patient using a concentrator reported that some water got into his nose and it was uncomfortable. What is the cause of this and how can this be dealt with? The model of the concentrator is AirSave New Life Elite. I'll ask one of our technicians to answer this one. Yes, Naomi, go ahead.
Thank you very much. So the condition that the patient encountered is called rainout. And basically, rainout refers to the condensation that develops and collects in the oxygen tubings when a humidifier bottle is being used with an oxygen concentrator. So if the condensation progresses to the point where it makes its way out of the tubing to the patient's nose, it can at times become very uncomfortable for the patient. So as we can see in the graphics, that is just an illustration of rainout, the condition rainout, where we have the air coming from the oxygen concentrator to the patient. So in the tubing, that's where the condensation happens, and it might happen that the water droplets get to the nose of the patient. So the best way that we can prevent rainout is to eliminate the humidifier. But there are some conditions where you can't use the concentrator without the humidifier. So I'll just look at some of the causes, some other causes of rainout and how we can solve them. So the first one is the length of the tubing. So if the tubing is long, is very long, and then it also passes through the flow, because of the difference in temperatures of the flows with the air in the tubing, it happens that the air in the tubings can condense more and hence have the water droplets getting into the patient's nose. So if we want to solve this problem, we can make sure that the tubing should be short, or if the tubings have to be long, say our beds are far away from the concentrators, we can make sure that they don't pass through the flow. And if there's no other way out of the tubings not passing through the flow, we can use a carpet on the floor so that the cord air, the temperature, the core temperature that comes from flow should not condense the air in the tubings. The second factor is having warmer air traveling through the tubings, that is, the air traveling through the tubings being warmer than the ambient air. So there's some concentrators that experience more rainout than others because they're generally warmer inside because of higher consumption. So higher power consumption, that is. So if the air that is passing through the tubings is at a higher temperature than the air in the atmosphere, it will end up condensing and then coming up with water droplets. So what we can do if we have this situation is to make sure we place our units 30 centimeters away from the wall so that it has adequate ventilation and the air inside the concentrator itself is cooler than the air outside the concentrator. So the other thing is that if we have humidifier bottles being overfilled, we'll have the water being pushed out together with the air into the tubings. So it will end up getting to the patient. But also the design of the humidifier bottle also determines whether there's going to be a lot of rain out or not. So there are two types of humidifier bottles. That is the flat top bottle and the dome top humidifier bottle. So with the flat top bottle, when the water droplets accumulate at the top of at the lid of the bottle, it can get pushed out together with the air into the tubings. But then when we have the dome-shaped humidifier bottle, when the air accumulates, when the water accumulates at the lid, it slides down the sides because of the dome shape, because it's more slanted than the flat top water bottle, humidifier bottle rather. So when we're getting our accessories for the oxygen concentrators, it is best to get the dome-shaped humidifier bottles as opposed to the flat-topped humidifier bottles. So as we can see in the graphics, on the left is a dome-shaped humidifier bottle, and on the right is the flat-topped humidifier bottle, which in this case causes a lot of rain out than the dome-shaped one. Thank you very much, and back to you, Sharon.
Thank you very much, Naomi, for that well-detailed explanation. So we have a hand from Morgeta. Please go ahead.
Yeah, it is common, especially for the humidifier bottle. There is a scale, the minimum, the maximum, and the moderate or the middle line. So mostly if you are filling to the maximum and beyond maximum with the water, especially the humidifier, so the high pressure, when you are releasing the high pressure, the water path with the oxygen through the nasal cannula or the other oxygen delivery devices. So the humidifier should have the medium size or medium level rather than maximum and minimum. So you have to keep the water level to the middle level. Thank you very much.
Thank you very much, Margeta, for that comment. We have no comments. We have a poll at the end of this question. So I'll ask Fatani to launch the poll.
Thank you, Sharon. So it's time for our second poll or the call. The poll reads, have you ever encountered a rainout condition while an oxygen concentrator is in use? Have you ever encountered a rainout condition while an oxygen concentrator is in use? So I'm going to launch the poll and give it some time so that the audience can vote. Just a reminder, if you're joining us from your mobile, you can access the polls by going to the bottom right corner of your mobile phone. There you see 3 dots, click on those 3 dots and then choose activities button, from where you can click on the polls and vote. If you're joining us from your computer, you can access the polls from the activities button that is located on the bottom right corner of your screen. The icon looks like it has a triangle, a square, and a circle. So click on that activities button and choose pause and then vote. Yeah, the votes are coming in and it's almost 50-50. 50% of us have ever encountered this rainout condition, and some 50% have never encountered this rainout condition. So if you have never encountered this condition, it means you are more careful when using the concentrator with a humidifier bottle. If you have encountered this, then you know how to deal away with this condition, because it becomes uncomfortable when the water gets to the nose of the patient, and this is not very good. And also, if the water goes back into the concentrator, we know that water can damage the zeolite in the sieve beds. So we need to make sure that water does not go back into the concentrator and the water does not go to the patient always, by following what Naomi and Mugeta have talked about. Now I'll end the poll and over to you, Sharon.
Thank you very much, Fatani. Now we move on to our next question. And it reads, hello, I'm a biomedical technician working on a delivery-based 515 oxygen concentrator that was producing low oxygen purity. Before opening it up, I decided to check the pressure at the patient outlet, and it was 58 kPa, which is the recommended pressure at the patient outlet in delivery-based 515. Even though the pressure was normal, I noticed that the bore in the flow meter was not dropping to the bottom of the flow meter whilst doing the pressure test. What can be the problem and how can I solve this one? I'll ask one of our technicians to answer this one. Yes, Masofa.
When doing a pressure test, an air path need to be completely sealed. So this means no air is allowed to pass through. So the ball needs to be at the bottom of the flow meter. So in your case, the ball is not going down to the bottom. It means there's some sort of a leakage that is pushing the ball up between the patient and the outlet of the flow meter inlet. Another possible source of of leakage is the pressure gauge itself. If the pressure gauge is broken in some sort of a way, it will allow air to escape out. So to solve such a problem, you will have to do a leakage test by either using a soapy water to see where the leak is, or by passing possible leakage spots and observing the position of the ball in the flow meter when you close the patient outlet using a thumb. Some of the possible leakage spots are in the bacteria filter, the flow meter itself, pressure gauge, oxygen sensor for the concentrators that have the sensor after the flow meter outlet, as well as a loose connection. When you solve the leakage problem, you will observe the ball will be able to drop down to the bottom of the patient outlet. Is completely sealed. Remember to do a pressure test again to make sure that the output pressure is within the range. There is a high possibility that the actual output pressure is higher in a way that if there was a leakage and you were getting normal output pressure, then after fixing the leakage, the pressure will go up. And since the pressure was initially higher, you will notice that the purity of the oxygen being produced might be higher than it was before. Thank you, Sharon.
Thank you very much, Masofa, for that well-detailed explanation. Any comments from the audience? If we have no comment, okay, we have a hand from Murugeta. Go ahead.
I think most of the time when we are maintaining or we are doing preventing maintenance, we have to not touching the regulator. There is inside the or some in some design there is in the above what you call it, the oxygen reservoir. There is a regulator, pressure regulator. So sometimes most of the people are touching that regulator. So the pressure is maybe changed. So you cannot see even the amount of, regulation. So it is not allowed to any technician to do that. But if there is a skilled person and he knows well, so he has to manage that issue. So mostly the main challenging issue in the hospital, remote areas, they are touching that regulators then they will change the range of the regulation or the pressure regulation. So that is one case. The other is kinking of the not only the liquid, the leakage, or sometimes there is a block, kinking of the tubes. So in all levels. So that will make the pressure difference. Thank you very much.
Thank you very much for that additional comment. So we have a poll at the end of this question, and I ask Fatani to launch the.
Thank you, Sharon. So it's time for another poll for the call. So the poll reads, have you ever done a pressure test on an oxygen concentrator? Have you ever done a pressure test on an oxygen concentrator? So I'm going to launch the poll now and give it time for the audience to vote. And just a quick reminder, if you're joining us from your mobile, you need to go to the bottom right corner of your mobile phone and click on the three dots there, choose activities button and click on pause. If you're joining us from a computer, on the bottom right corner of your screen, you'll see to the far right an activities button. Click on that and then choose pause so that you can be able to vote for the poll that I've just launched. So let's keep voting. The votes are still coming in. Yeah, it looks like everyone has voted and the yeses carry the day. So it looks like most of us have ever done a pressure test on a concentrator. Aside from the purity test, the pressure test on oxygen concentrator is another common test that we do when maintaining this oxygen concentrator. So if you've ever maintained an oxygen concentrator, either refilled the beds or anything else in terms of maintenance, you may have done this pressure test at some point. Now I'll end the poll and over to you, Sharon.
Thank you very much, Fatani. So just a reminder to our new members, please do share with us your emails in the chat so that we can add you to our emailing lists. So reaching this far, we'll take a slight diversion to today's topic of interest. And today, Kevin Saidi will be taking us through today's topic of interest. So over to you, Kevin.
Thank you so much, Sharon. So in today's topic of interest, we'll be talking about some of the ways that we can follow in order to reduce the humidity of the room. So in most cases, as technicians work on oxygen concentrators, we reduce the humidity mainly because we want to refill zeolite. So in general, you can define humidity as the concentration of water vapor that is present in the air. So water vapor is a gaseous state of water, and it is generally invisible to the human eye. And the most common primary measurement of humidity is relative humidity. And this is a ratio of the amount of atmospheric moisture that is present relative to the amount that would be present if the air were saturated. And this ratio is expressed in a percentage form. So humidity can affect people in general in the following ways. The first way is that people depend on perspiration, also known as sweating, in order to regulate their internal body temperature. So if you're in an area of high humidity, this process is impaired and you can have difficulties in maintaining your body temperature, which can lead to other complications. And the second effect is that humid air has been found to be heavy to breathe, and it may pose difficulties in people with breathing conditions such as asthma. And these are just two ways in which high humidity can affect people. I've just mentioned a few. But as earlier mentioned, high humidity negatively affects oxygen concentrators in general. As I said, when you are undertaking oxygen concentrator repairs and maintenance, there might be a need for refilling the sieve beds with new zeolite. And as most of us know, zeolite is a substance that has a high affinity for moisture. And when it absorbs this moisture, it degrades. And this implies that it will lose its ability to separate the nitrogen from the air efficiently, and it will lead to low oxygen purity for our machines. So in order to avoid this contamination, I would recommend to do the refilling process in a room only if the humidity is below 50%. And this is because the moisture content below this humidity level doesn't affect the zeolite performance. So before refilling zeolite, you need to check the humidity level of your room by using a humidity monitor. So you can buy one of these monitors for about $20 on Amazon. Another alternative is to build one of your own. All you need is a microcontroller, a humidity sensor, and an LCD display, and some bit of coding, and you have your own humidity sensor as shown in the graphics. So sometimes the humidity can be above 50%, and there is need to drop it in order to do the zeolite filling process. So I'll explain a number of ways that can be used to reduce the humidity. The first and most obvious way is to use a machine that is called a dehumidifier. And this machine works by drawing air from your room at one end. It takes the moisture out and then blows it back into the room again. So the moisture that is trapped condenses into a collection tank, and you have to empty it from time to time. So all dehumidifiers work in one of two ways. It's either by refrigeration or by using the mopping method. With the refrigeration method, warm, moist air is sucked in through an opening on one side of the machine, and the warm air passes over freezing cold pipes through which a coolant is circulating with the help of a compressor. As the air cools, the moisture it contains turns back into liquid water and drips down off the pipes. And now this moisture-free air passes over the hot condenser or compressor, and this warms it up back to its original temperature. The warm, dry air blows back into the room through an outlet, and the moisture that was in the air is collected in a collecting bucket at the bottom of the machine. With the mopping method, the the water in the air is separated by using a water holding material, and then this moisture is then squeezed out in some different ways out to the atmosphere. So the mopping action involves either absorption. This is where the water soaks right into the moisture absorbing material, or adsorption, where water is picked up on the surface of something. So moist air is drawn into the machine and it passes this moisture absorbing material, and then dry air is then released into the atmosphere. Now this moisture absorbing material is then heated and air is blown in order to drive the water vapor away. So these dehumidifiers, they're mostly installed next to walls so that the exhaust of the water vapor goes outside of your room. Yeah. So in general, a dehumidifier is very effective in reducing humidity, but the only drawback is that it is quite expensive to purchase. The least expensive I found was for at least $200 on Amazon. Yeah. The second way in which you can use to reduce the humidity of the room is by using an air conditioner. So I've explained about the refrigeration process. So an air conditioner has a similar mechanism to these refrigeration dehumidifiers. So they use the same mechanism, and that can be able to reduce the humidity. So if you have an air conditioner, you might not need to buy a dehumidifier. That air conditioner can be an alternate solution to that. So it is also important to check the filters of your air conditioner. If the filters are compromised, they won't be able to effectively reduce. They won't be able to effectively reduce the humidity of your room. Another way is by using what we call desiccant. So a desiccant is a hygroscopic substance that is used to sustain a state of dryness in its surrounding. So a hygroscopic substance is a substance that is able to absorb water. So some examples of desiccants include silica gel, we have cat litter, rock salt, and charcoal. So you have the normal charcoal briquettes and activated charcoal. So if you can put a basket of charcoal in a room, after some time, the charcoal that was placed in the room gets damp. And it gets damp, implying that it has absorbed the moisture that was surrounding it. And this damp charcoal can be reused after drying it in the sun. So the use of desiccants is advantageous because it is cheaper than the alternatives I've mentioned above, the air conditioner and the humidifier. And putting it in a room and it does the work. Whereas the dehumidifier and the air conditioner will require electricity, which will incur some further costs. The only disadvantage to this is that it has a slow rate of moisture absorption. And another way is by drying rags that we use when cleaning the workshop benches outside. So in some cases, you might spill water or any other liquid in your workplace. So when you use rags to dry these surfaces, do not leave them hanging in the workshop, because if the rags dry, the moisture will still remain in the room. This will contribute to the increase in humidity. So it is good practice to dry your rags outside of your rooms. Also, if you wash your work suits at work, do not dry them inside. Find a cloth line, and you'll be able to dry them outside in order to reduce the humidity. Another thing is by using an enclosed room when refilling zeolite. So if you are refilling zeolite in open spaces, you could be exposing the zeolite to uncontrollable humidity, and this will negatively affect the performance of zeolite. So if you want to easily control the humidity, I advise that you find an enclosed room where you keep all air entry points, such as windows, doors. You keep them closed, and this is to prevent air entry points This is to prevent air that has high humidity from occupying the space. And after enclosing the air entry points, you can use a humidity monitor to visually see if the humidity has dropped to a desired level. And you can also use one of the three above alternatives to further reduce the humidity. That marks the end of the topic of interest today. Thank you. Over to you, Sharon.
Thank you very much, Kevin, for that explanation. Any questions for Kevin or any additional comments? Okay. If we have no further questions or comments, this marks the end of today's Concentrator Talk. So I'd like to thank you all for joining us for this week's Concentrators Talk. So for our new members, please share with us your emails so that we can add you to our emailing list, as this will allow us to send you updates when new materials have been added. And remember, we'll be meeting again here next week, same time. So if you have any questions, please send them to us in advance through our email, info@oxygenalliance.org, and we'll do our best to help you with the required solutions. Be sure again to visit our website, www.oxygenalliance.org, to learn more about Oxygen Alliance and all the work that we do. So we also have a YouTube channel where all the recorded videos of the previous Concentrator Talks have been posted. So please check it out and remember to subscribe. So reaching this far, it's goodbye.